You know, whenever I find myself standing beneath a truly dark sky, perhaps in the high Atacama Desert or deep in the Australian outback, away from the light pollution of our cities, I am always struck by two contradictory sensations. The first, of course, is a sense of overwhelming majesty. The sheer scale of it. You look up and you are seeing history. You are seeing the light from stars that may have died millions of years ago, traveling across the vast, cold vacuum to reach your retina at this precise moment. It is a connection to the infinite. But the second sensation, the one that lingers long after you've packed up your telescope and gone inside, is a profound sense of unease. It is the sensation of silence. Because when you really understand what you are looking at, when you understand the numbers, the statistics, the sheer probability of the cosmos, that silence becomes deafening. It becomes the loudest thing in the universe. We call this the Fermi Paradox, named after the physicist Enrico Fermi, who over a casual lunch in 1950 asked a question that was devastatingly simple. Where is everybody? It is a question that haunts us. It haunts every astronomer who has ever turned a radio telescope towards the stars and heard nothing but the hiss of cosmic background radiation. It haunts every philosopher who has wondered if we are truly alone, because the math suggests we shouldn't be. Our galaxy, the Milky Way, is ancient. It is roughly 13.6 billion years old. It contains something like 400 billion stars. And we now know, thanks to the Kepler Space Telescope and other missions, that planets are common. Almost every star has them. Billions of those planets are Earth-sized, sitting in the habitable zones of their parent stars, where water can exist as a liquid, where the chemistry of life can begin. So you have billions of stages, and you have billions of years for the play to begin. Even if life is rare, even if intelligence is a 1 in a billion fluke, there should be millions of civilizations out there. Some of them should have arisen billions of years before us. And if you have a billion-year head start, you don't just build better iPhones. You reorganize your solar system. You build structures that capture the entire output of your star. You spread, you colonize. You make your presence known, not because you want to, but because you can't help it. A galactic civilization should be as obvious as a bonfire on a dark hill, and yet we see nothing. No Dyson spheres blocking the light of stars. No meaningful radio signals. No probes entering our solar system. Just silence. Now, over the decades, we have come up with all sorts of explanations for this silence. And most of them, I have to say, are rather anthropomorphic. They are based on human psychology or human sociology. We tell ourselves that perhaps they are hiding, following some prime directive not to interfere with primitive species like us. Or perhaps they are all living in virtual realities, hooked into some matrix, uninterested in the physical universe. Or perhaps they are simply too far away. But I want to suggest something else, something that is far more fundamental and perhaps a little more disturbing. But I want to suggest that the reason we haven't met them, the reason the sky is silent, has nothing to do with their psychology. It has nothing to do with their choices. It isn't that they are hiding. It isn't that they are shy. It is that the universe itself, through the fundamental laws of physics, prevents them from existing in the way we imagine. We tend to think of the laws of physics as things that enable us. We understand gravity, so we can fly to the moon. We understand electromagnetism, so we can build the internet. But the laws of physics are also constraints. They are the walls of our cell, and there are physical explanations for the Fermi Paradox that don't rely on alien psychology, but rather on the cold, hard realities of thermodynamics, of energy, and of distance. To understand this, we have to look at what a civilization actually is. At its most basic level, stripped of culture and art and politics, a civilization is a mechanism for processing energy. That is what we are. That is what any living thing is. We take energy from our environment, food, sunlight, fossil fuels, nuclear fission, and we use that energy to create order. We use it to build our bodies, our cities, our computers. We use it to fight against the second law of thermodynamics, which states that the universe tends towards disorder, towards entropy. Life is an island of order in an ocean of chaos. And maintaining that island requires a constant flow of energy. Now, consider the trajectory of a civilization like ours. For the last few centuries, our energy consumption has grown exponentially. We went from burning wood to burning coal to burning oil to splitting the atom. And every step of the way, we have assumed that this growth can continue indefinitely. We assume that a civilization 1,000,000 years older than us will consume 1,000,000 times more energy. We imagine them harnessing the power of entire stars, spanning across the galaxy, their energy needs growing and growing without limit. But here is where the physics begins to push back. Here is where the universe says stop. Because energy use has a cost. And I don't mean a financial cost. I mean a physical cost. You cannot use energy without producing waste. This is not a technological limitation. It is a fundamental law of nature. The second law of thermodynamics tells us that whenever you do work, whenever you process information, whenever you build a structure, you must increase the entropy of the universe. And that entropy usually manifests as heat, waste heat. It doesn't matter how advanced your technology is. It doesn't matter if you have fusion reactors that are 99.9% efficient. It doesn't matter if you are using quantum computers or black hole drive systems. If you use energy, you produce heat. And this leads us to a concept that is often overlooked in our science fiction fantasies of galactic empires, the thermodynamic ceiling. Imagine a civilization that keeps growing on its home planet. It uses more and more energy. Eventually, the waste heat from its machinery, its computers, its transport becomes so great that it rivals the heat coming from its own sun. The planet starts to cook. Not from the greenhouse effect, not from carbon dioxide, but simply from the raw heat of its own industry. To survive, they have to move off planet. They have to build habitats in space. So they do. They build giant swarms of satellites, collecting solar power. They expand, but the problem follows them. You see, the galaxy is not just a collection of stars. It is a vast, cold vacuum. And getting rid of heat in a vacuum is incredibly difficult. On Earth, if you have a hot engine, you can air cool it. The air takes the heat away. And in space, there is no air. You can only get rid of heat by radiating it away as infrared light. And that is a slow, inefficient process. This means that any civilization, no matter how advanced, faces a hard limit on how dense it can be and how much it can grow. They cannot simply expand indefinitely. They are constrained by the ability to shed waste heat. But it goes deeper than just heat. It goes to the very nature of complexity itself. We look at the exponential growth of our own technology, Moore's law, the explosion of the internet, the rise of AI, and we extrapolate that line upwards forever. We assume that in 1,000 years we will be godlike. But in nature, exponential growth never lasts forever. It always creates the conditions for its own collapse. Bacteria in a petri dish will grow exponentially until they run out of food or poison themselves with their own waste. Stars burn brighter and hotter until they exhaust their fuel and die. Why should civilizations be any different? We assume that intelligence exempts us from these laws. We think that because we are smart, because we can invent things, we can cheat the system, we can invent our way out of resource scarcity. We can invent our way out of pollution. But you cannot invent your way out of the laws of thermodynamics. You cannot invent your way out of the fact that order is expensive. So perhaps the silence out there is not because there is no life. Perhaps the galaxy is teeming with life. Perhaps there are millions of worlds where bacteria and moss and simple animals have existed for eons. Perhaps there are even thousands of worlds where intelligent beings have arisen, looked up at the stars, and dreamed of conquest. But perhaps they all hit the same wall, the wall of physical reality. They reach a point where their energy consumption begins to destabilize their planetary environment. They reach a point where the complexity of their society requires so much energy to maintain that it becomes fragile. And then the collapse comes. Not necessarily a nuclear war or an asteroid impact, but a thermodynamic collapse, a return to simplicity. This suggests that the window of time in which a civilization is loud, capable of sending radio signals, capable of launching rockets, capable of dreaming of empire, is vanishingly short. It might be a few centuries, a few thousand years at most, in the context of a universe that is 13.8 billion years old, that is a flicker, a spark in the dark. And if that is true, if civilizations are like flashes of lightning in a thunderstorm brief, intense and disconnected, then it is no wonder we see nothing. We are simply looking at the wrong time. We are looking for something that is permanent, when we should be looking for something that is ephemeral. But there is another trap, a trap of scale. Even if a civilization manages to stabilize its energy use, even if they manage to live sustainably on their home world, or perhaps in a small cluster of habitats around their star, even if they survive for millions of years, why haven't they come here? Why haven't they sent von Neumann probe self-replicating machines to colonize every star in the galaxy? Mathematics tells us that a single civilization sending out probes that travel at even a small fraction of the speed of light could colonize the entire Milky Way in just a few million years. A few million years is nothing in cosmic time. It's a blink of an eye. So if anyone had ever done it, they should be here already. The fact that they aren't here tells us that interstellar travel is harder than we think. Much harder. We are seduced by science fiction. We watch Star Trek or Star Wars, and we see ships zipping between stars as if they are driving to the supermarket. We press a button, engage the warp drive, and we are there. But in the real universe, the universe of Einstein and Planck, distance is a monster. The nearest star to us, Proxima Centauri, is 4.2 light years away. That is roughly 40 trillion kilometers. To get there with our current technology would take us nearly 70,000 years. Even if we could build a ship that travels at 10% of the speed of light, which would require an amount of energy equivalent to the entire global energy consumption for decades, it would still take over 40 years to get there. And that is just the nearest star. The galaxy is 100,000 light years across. The energy required to move matter across these distances is astronomical. And again, it's not just about engineering. It's about the fundamental cost of doing business in the universe. To send a human being to another star, you have to keep them alive. You have to protect them from cosmic radiation. You have to provide food, water, air, gravity. You have to take a piece of Earth with you. And the more mass you take, the more energy you need to accelerate it. And the more energy you need, the more fuel you have to carry, which adds more mass, which requires more energy. It is the tyranny of the rocket equation, writ large across the cosmos. So perhaps the reason we don't see galactic empires is that they are physically impossible, not because of a lack of ambition, but because the energy cost of moving a civilization from one star to another outweighs any possible benefit. Why would you do it? Why would you spend the energy output of your sun to send a few thousand individuals to a distant rock that you then have to terraform for thousands of years? What is the economic driver? What is the evolutionary driver? On Earth, we expanded because there were resources to be had. We crossed oceans because there was land on the other side. But in space, the oceans are 99.9999% of the journey, and they are filled with radiation and death. And the land on the other side is usually a dead rock that is far worse than the harshest deserts on Earth. It forces us to reconsider the very idea of a spacefaring civilization. We assume it is the natural next step. We assume that a species starts on a planet, develops technology, and then leaves the nest. But what if the nest is all there is? What if the planet is the only place where a biological species can truly flourish? This leads us to a fascinating and slightly terrifying thought, that the universe is not designed for travel, it is designed for isolation. The distances between the stars act as a quarantine. They ensure that what happens in one solar system stays in that solar system. A civilization can rise, flourish, create art and science, and eventually die without ever influencing another civilization. We are trapped in bubbles of causality, separated by gulfs of space-time that are effectively unbridgeable for biological entities. And this brings us back to the idea of the great filter. The great filter is the idea that there is some hurdle, some obstacle in the development of life that is extremely difficult to cross. People usually look for this filter in the past. Perhaps the origin of life is hard, or the origin of intelligence is hard, or they look for it in the future, nuclear war, AI, climate change. But I would argue that the great filter is simply the laws of physics themselves. The filter is the distance. The filter is the energy cost. The filter is the fact that the universe is vast and we are small and heavy and fragile. It implies that the silence is the natural state of the cosmos, that the universe is not a community waiting to be joined, but a collection of lonely islands. And while that might sound depressing, while it might sound melancholy, I think there is a profound truth hidden in there, a truth about value. If we cannot easily leave, if we cannot easily spread, then what we have here becomes infinitely more precious. But before we get to the meaning of it all, we have to look closer at this thermodynamic trap, because it's not just about space travel, it's about existence itself. It's about the very engine of life and how it relates to the death of the universe. When we look at the history of life on Earth, we see a constant battle against equilibrium. Equilibrium is death. Thermal equilibrium is when everything is the same temperature, when no energy flows, when nothing happens. Life is a struggle to stay away from equilibrium. And to do that, we need a gradient. We need a source of high-quality energy, the sun, and a place to dump our low-quality waste, heat, the cold sky. This flow from hot to cold is what powers the complexity of the biosphere. It is what powers your brain as you listen to this. It is what powers the weather, the oceans, the forests. We are effectively just eddies in a river of energy, swirling patterns that persist for a moment before dissolving back into the flow. Now, apply this to a technological civilization. We are trying to build bigger and more complex eddies. We are trying to create structures that are even further away from equilibrium. And the further you get from equilibrium, the harder the universe pushes back. The more energy you need just to stand still. This is why the dream of infinite growth is a physical impossibility. It violates the basic accounting of the universe. You cannot have infinite growth in a finite system. And ultimately, even the galaxy is a finite system. But the limits hit us much sooner than that. They hit us right here on the surface of our world as we build our civilization, as we construct our cities and our data centers. We are essentially fighting a war against entropy. And entropy is a patient enemy. It doesn't have to win today. It doesn't have to win tomorrow, but it always wins in the end. The more complex our society becomes, the more energy it takes to maintain it, and the more fragile it becomes to disruption. This might be the true explanation for the Fermi Paradox. Not that civilizations blow themselves up, but that they simply run out of steam. They hit the point of diminishing returns. The energy required to solve the next problem, to make the next leap, becomes greater than the energy available. And so they plateau. They stop looking outward. They turn inward, focusing on efficiency, on survival, on the maintenance of what they have. They become quiet. So when we look out at the Milky Way, we shouldn't expect to see empires. We shouldn't expect to see waves of colonization sweeping across the stars. We should expect to see quiet, stable, introspective worlds. Worlds that have learned the hard lesson of thermodynamics. Worlds that have accepted their limits. And this leads us to a specific physical constraint that is often ignored, something that ties us to our planet even more tightly than gravity. It is the constraint of biology itself. We are not just energy processing machines. We are biological organisms. We are made of soft, wet, fragile matter. We evolved in a very specific environment with a very specific gravity, a very specific atmospheric pressure, a very specific radiation background. We tend to think that technology can overcome biology, that we can build spacesuits and habitats and eventually genetically engineer ourselves to live in space. And to a certain extent, we can. We can visit space. We can stay there for a while. But to live there, to thrive there, to build a civilization that lasts for thousands of years in the void, that is a different proposition entirely. And when you look at the sheer hostility of the universe outside our protected magnetic field, you begin to realize that our biology is not just a feature, it is a tether that binds us to the earth with a strength that no rocket can break. Consider the complexity of a single human body. You are a colony of 30 trillion cells. You are a microbiome of bacteria and viruses. You are a symphony of chemical reactions that have been fine-tuned over 4 billion years of evolution to work in this specific environment. Take that system and place it in a high radiation microgravity environment and it begins to fall apart. Bones lose density. Eyesight fails. The immune system malfunctions. DNA shatters. We are not made for the cosmos. We are made for the earth. And this realization that we are biological entities first and space travelers second adds another layer to our physical explanation of the silence. It suggests that intelligence is not a generic software that can run on any hardware in any environment. It suggests that intelligence is deeply, inextricably linked to the biosphere that created it. To take a civilization away from its home planet might be like trying to take a brain out of a body. You might be able to keep it alive in a jar for a while, but it is no longer truly living. It is no longer functioning as it was meant to. It is a ghost. And perhaps that is what spacefaring civilizations become. Ghosts, fading echoes of what they once were, struggling to maintain their complexity in a universe that is trying to tear them apart. Maybe they don't die out. Maybe they just wither. They realize that the cost of leaving is too high and the reward is too low. So they stay home. They tend their gardens. They look up at the stars with wonder, but without the need to possess them. They understand that the stars are not there to be conquered. They are there to be admired from a distance. But this perspective changes everything. It changes how we see our future. It changes how we see ourselves. If the silence is inevitable, if the isolation is physical, then our loneliness is not a failure. It is a feature of reality. And it makes this moment, here, now, even more extraordinary. But to truly grasp the implications of this, we need to look deeper into the nature of that thermodynamic ceiling I mentioned. We need to understand exactly why energy is the ultimate currency of the universe and how the pursuit of it might be the very thing that traps us. Because the story of life is the story of energy capture, but the story of the universe is the story of energy dissipation. And we are caught right in the middle. And to understand that story, we have to go back to the very beginning, not the beginning of history or even the beginning of life, but the beginning of the laws that govern them, the laws of thermodynamics. There is a saying in physics, attributed to Arthur Eddington, that if your theory disagrees with Maxwell's equations, then so much the worse for Maxwell's equations. If your theory disagrees with observation, well, these experimentalists do bungle things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. The second law is supreme. It states that in any closed system, entropy, which you can think of as disorder or uselessness, must always increase. Things fall apart, structures decay, energy spreads out. The coffee gets cold. The star burns out. The universe marches inevitably towards a state of uniform dullness. But life seems to contradict this. You look at a human being, or a tree, or a civilization, and you see order, you see structure, you see complexity arising out of chaos. How is this possible? Are we breaking the law? No, we are not breaking the law. We are exploiting a loophole, or rather, we are paying a price. We create local order by creating a vast amount of disorder elsewhere. We are, in the language of physics, dissipative structures. We exist by taking in high-quality energy, using it to build and maintain our complex internal structure, and then spitting out low-quality energy heat into the universe. We are engines. That is all we are. And this is where the trap lies, because we have convinced ourselves that the purpose of a civilization is to grow, to get bigger, to use more energy, to process more information. We measure our success by our GDP, which is effectively a proxy for our energy consumption. We assume that a type I civilization on the Kardashev scale, one that uses all the energy falling on its planet, is better than a type 0 civilization like ours. We assume a type II civilization, one that uses all the energy of its star, is the goal. But thermodynamics tells us that there is a penalty for this ambition. The universe demands a tax on every single transaction. Let's imagine for a moment that we solve all our energy problems. Let's say we master nuclear fusion. We have unlimited clean energy. We can build as many reactors as we want. We can desalinate all the oceans. We can build vertical farms to the sky. We can run supercomputers that simulate entire universes. We can keep growing. What happens then? Well, that energy has to go somewhere. You use the electricity to run a computer. The chip gets hot. You use it to move a car. Friction creates heat. You use it to grow food. The metabolism of the plants and the people eating them produces heat. All energy eventually degrades into heat. And here is the hard physical truth that no amount of technology can bypass. Earth can only radiate a certain amount of heat into space. It's a balance. We receive energy from the sun, and we radiate energy away as infrared light. If we generate too much of our own heat waste, heat from our miraculous fusion reactors, we upset that balance. The planet warms up. And I am not talking about global warming caused by CO2. That's a chemical problem. We can solve that. I am talking about direct heating. If we keep increasing our energy consumption at the current rate, just a few percent a year, which is what our economists demand for healthy growth, then within a few hundred years, the waste heat alone will boil the oceans. It doesn't matter if the energy is clean. It doesn't matter if it's solar, wind, or fusion. The heat is the inevitable byproduct of the work done. This is the thermodynamic ceiling. It is a hard wall. So, a civilization on a planet has a choice. It can stop growing. It can reach a level of technological maturity where it stabilizes its population and its energy use, living in balance with the heat budget of its world. It becomes a steady state civilization, quiet, efficient, invisible to the rest of the universe. Or it can try to expand. It can move into space. It can build one-eel cylinders, Dyson swarms, vast megastructures to capture the light of its star. And this is what we expect to see when we look for aliens. We expect to see the infrared signature of these massive engineering projects. We expect to see stars that are dimmer than they should be because a Dyson sphere is blocking the light, but we don't see them. And I think I know why. Because the transition from a planetary civilization to a stellar civilization is not just an engineering challenge, it is an evolutionary trap. Think about the sheer stability required to build a Dyson sphere. You are dismantling planets. You are coordinating the efforts of billions of individuals over thousands of years. You need a political and social stability that lasts longer than the recorded history of the human species. And you are trying to do this while your energy consumption is skyrocketing, while your society is becoming infinitely complex. Complexity is dangerous. In engineering, we know that the more moving parts a machine has, the more likely it is to fail. A simple stone axe lasts forever. A nuclear power plant requires constant, perfect maintenance. A galactic empire, that is a machine with trillions of moving parts. As a civilization grows in energy use, it grows in volatility, it becomes a loaded gun. The power to build a starship is the power to destroy a biosphere. The power to edit DNA is the power to create a pandemic. The power to create artificial intelligence is the power to make yourself obsolete. So as you climb the ladder of energy, the margin for error shrinks. You have to be perfect. Every single day. Forever. One mistake, one miscalculation, one act of malice, and the whole delicate, high-energy structure comes crashing down. Thermodynamics favors the simple. It favors the low-energy state. It favors the rock over the rocket, the bacteria over the brain. This suggests that there is a great filter built into the physics of complexity. It's not that aliens get wiped out by death rays. It's that they simply collapse under their own weight. They reach a level of complexity that is unsustainable, and they fragment, they fall back. They might not go extinct, but they lose the capacity for interstellar ambition. They return to the mud, or at least to a simpler agrarian existence, forced by the laws of physics to simplify or die. And this cycle might happen over and over again. Civilizations rise, they burn bright, they consume their resources, they heat up their worlds, and then they collapse. Like bubbles in a boiling pot. Pop, pop, pop. And the universe remains silent, because no one stays loud long enough to be heard. But let's assume for a moment that a species manages to thread this needle. Let's assume they are wiser than us. They stabilize. They don't collapse. They decide to expand slowly, carefully. They build a ship. They decide to cross the void. Now they face the second physical monster, time. We are biological creatures, and our perception of time is biological. We think a year is a long time. We think a century is an era. We think a millennium is history. But the galaxy operates on timescales that make those numbers meaningful only as rounding errors. To cross the galaxy, even at high speeds, takes hundreds of thousands of years. To colonize, it takes millions. Imagine a ship leaving a home world. It travels for 1,000 years to reach a nearby star. The people on that ship, generations of them, will evolve culturally, linguistically, perhaps even biologically. By the time they arrive, they are no longer the same people who left. They are no longer part of the same civilization. They are aliens to their own ancestors. They settle the new world. And then silence, because communication is impossible. If you send a message to the homeworld, we arrive safely, and it takes 10 years to get there and 10 years to get a reply, you cannot have a conversation. You cannot have a government. You cannot have a shared culture. The colony becomes an island utterly cut off from the mainland. And this happens with every new star. The civilization doesn't spread as a unified empire. It spreads like a gas, diffusing into the void, each molecule forgetting where it came from. There is no galactic federation. There is just a scattering of lonely outposts, each one evolving in its own direction, each one facing its own local struggle against entropy, each one eventually forgetting that there is anyone else out there at all. This is the tyranny of light speed. It ensures that the universe remains a collection of villages, never a city. And this isolation feeds back into the thermodynamic problem. Without the support of a larger network, without trade, without the exchange of ideas and resources, each of these colonies is incredibly vulnerable. A small colony on a hostile world is on a knife edge. A single crop failure, a single equipment malfunction, and they are gone. We look at the history of human colonization on Earth, Roanoke, the Vikings in Greenland, and we see how easy it is for a colony to fail even here on our own home planet. In space, the margins are infinitely tighter. The cold is colder. The radiation is deadlier. The isolation is total. So it is very likely that the galaxy is full of the ruins of failed colonies, monuments to the hubris of species that thought they could defeat the distances. But there is an even deeper reason why the silence might be inevitable, and it has to do with the nature of intelligence itself. We assume that intelligence leads to expansion. We assume that smart beings want to conquer the universe. But why do we assume that? We assume it because we are expansionist. We are the descendants of the explorers, the conquerors, the ones who couldn't sit still. But that is a specific evolutionary trait of Homo sapiens. It is not necessarily a universal constant of intelligence. Consider the dolphin. Dolphins are incredibly intelligent. They have complex language, social structures, self-awareness, but they have no technology. They have no fire. They have no desire to leave the ocean. They are perfectly content to exist within their environment. Or consider a superintelligence, an AI, or a biological species that has enhanced its own mind. What does a superintelligence do? Does it build giant spaceships? Or does it go inward? If you can simulate a universe inside a computer with perfect fidelity, why would you bother with the messy, dangerous, slow, boring, real universe? in a simulation. You can control the laws of physics. You can live for 1 billion years in a single second. You can experience every pleasure, solve every puzzle, create every art form. The physical universe, by comparison, is a desert. It is mostly empty space. It is cold. It is dangerous. It is slow. So perhaps the most advanced civilizations don't expand. They sublime. They turn their planets into giant computers, burrow into the quantum foam, and leave the physical world behind. They don't want to talk to us for the same reason you don't want to talk to an anthill, not because they are arrogant, but because their reality is simply orthogonal to ours. They have moved into a realm of density and information that we cannot even comprehend. They are looking in, not out. And so the physical universe is left to the primitives, to the species like us, who are still struggling with matter and energy, who are still obsessed with moving rocks from one place to another. We are the noise in the silence. But even we will eventually face the choice, inward or outward, simulation or stagnation. And every time we look at the physics, the arrow points inward. The efficiency is higher. The speed is faster. The possibilities are greater. This leads to a rather beautiful, if somber, conclusion. The reason we don't see space empires is that space empire is a primitive concept. It is a projection of our own colonial past onto the future. It is thinking of the galaxy as just a bigger version of the Atlantic Ocean. But the galaxy is not an ocean. It is a different kind of existence entirely. The silence is not empty. It is heavy. It is heavy with the weight of civilizations that have turned away from the void or collapsed trying to conquer it. But let's bring it back to us, to you and me, standing on this fragile rock. What does this mean for our future? If the thermodynamic ceiling is real, if the distance is a prison, if the logical endpoint of intelligence is introversion, are we doomed? Is the dream of Star Trek a lie? In a way, yes. We have to grow up. We have to put aside the childhood toys of warp drives and lightsabers. We have to look the universe in the face, the real universe, the universe of limits. We often talk about the hostility of space, but hostility implies intent. The universe isn't hostile. It is indifferent, but that indifference is lethal. The vacuum doesn't hate you. It just doesn't care if you boil. The radiation doesn't want to kill you. It just tears through your DNA, because that is what high energy particles do. And this brings us to the most overlooked factor in the Fermi Paradox, the biology, the meat. We treat our bodies as vehicles for our minds. We think that as long as we can build a tin can that holds air, we can take these bodies anywhere. But we forget that we are not just passengers in these bodies. We are these bodies. And these bodies are not generic. They are specific. They are tuned. You are 4 billion years of evolutionary fine-tuning. Your circadian rhythms are locked to the 24-hour rotation of this planet. Your blood pressure is calibrated to 1 gram of gravity. Your gut bacteria, which control your mood and your immune system, are adapted to the specific chemical environment of Earth's food web. We know now that when astronauts spend even a few months in space, the degradation is terrifying. The heart shrinks, the bones dissolve, the eyes flatten, the immune system gets confused, the genetic expression changes. We are not adapting to space. We are surviving it, barely. And that is just in low Earth orbit, inside the protective embrace of the Van Allen belts. Out there, in the deep black, the cosmic rays are like bullets. They shred the synaptic connections in the brain. They create a fog of cognitive decline. Imagine sending a generation ship to another star. You are putting human beings, creatures evolved for the savannas and the coasts, into a metal box, exposing them to chronic radiation, zero or artificial gravity, recycled air, and a limited gene pool for centuries. What arrives at the destination will not be human, not in the way we understand it. They will be mutants. They will be frail, possibly insane, genetically damaged remnants of the proud explorers who left. Is that a future? Or is it a nightmare? We have this arrogance that we can engineer our way out of anything. We say we will just genetically modify ourselves. We will become cyborgs. We will upload our minds. Maybe. But then we are no longer talking about human expansion. We are talking about something else, something post-biological. And if we become machines, do we still have the drive to explore? Do machines care about sunsets on alien worlds? Do machines feel the urge to plant a flag? Or do they just calculate the most efficient use of resources and shut down the engines to save power? The more we strip away our biology to survive the journey, the more we strip away the very reasons we wanted to go in the first place. We go because we are curious, because we are passionate, because we are lonely. Machines are none of those things. So the biology acts as another filter. A soft filter, perhaps, but a sticky one. It keeps us here. It whispers to us that we belong to the soil, not the stars. And there is a profound physics in that belonging, the concept of resonance. In physics, systems work best when they are in resonance with their environment. A bridge stands because it resonates with the forces acting on it. An atom is stable because its electrons are in resonance. Life is a resonance with the planetary environment. We are the song that Earth sings. To take the song away from the instrument is to destroy it. You cannot play a violin concerto on a vacuum. This realization forces a shift in perspective, a shift from conquering space to inhabiting Earth. If the universe is a ladder of increasing entropy, then Earth is a miracle of low entropy. It is a gem, a rare, fleeting, unstable configuration of matter that allows for the existence of Shakespeare and Beethoven and particle physics. And it is maintaining this low entropy state against the crushing weight of the universe's disorder that is hard work. That is the work of the biosphere. And we are disrupting that work. We are adding heat. We are breaking the cycles. If we understand the Fermi Paradox as a warning, as a signpost saying dead end ahead for high energy civilizations, then our priority changes. The goal is not to see how much energy we can use. The goal is to see how much meaning we can create with the energy we have. It is a shift from quantity to quality, from extensive growth spreading out to intensive growth deepening in. The silence of the stars is not a challenge to be overcome. It is a lesson to be learned. It is telling us that the default state of the universe is dead matter, that life is the exception, that consciousness is a flickering candle in a hurricane. And you don't take a candle out into a hurricane to see better. You cup your hands around it. You protect it. You keep it burning where it can survive. This is the simple physical explanation. It's not aliens. It's not conspiracy. It's just the laws of nature doing what they always do, leveling, cooling, separating. But we are not done yet. Because even if we accept that we are trapped, even if we accept the heat death and the distance and the biological anchor, there is still the question of why. Why does the universe allow for this complexity at all? If the second law is so powerful, why are we here? Why is there a window of time, a Goldilocks era in the history of the cosmos, where life is possible. And what does that say about our ultimate responsibility? Because if we are effectively alone, if the nearest neighbor is 1,000,000 years away or dead, then the value of this planet, this one singular blue dot, goes up to infinity. We are not just one of many. We are, for all practical purposes, the only one, the only eyes the universe has, the only mind that can contemplate the equation. And that brings us to the ultimate tragedy and the ultimate hope of our situation. The prison of light, and biology is also a sanctuary. And in the next part of our journey, we have to look at the walls of this sanctuary, not as barriers, but as the very things that define us. We have to look at the darkness between the stars and find the beauty in the isolation, because only by accepting the silence can we truly hear the music of our own existence. And so we find ourselves standing at the edge of a precipice, looking out into the dark. We have spoken about the heat that limits our industry and the biology that ties us to the soil. But there is a third wall to our prison, perhaps the most formidable of them all. It is a wall built not of matter, but of geometry. It is the wall of light. When we look at the stars, we are often told that the speed of light is fast, and in human terms, it is 300,000 kilometers per second. It is fast enough to circle the Earth 7 times in a heartbeat. It is fast enough to turn communication on our planet into something instantaneous. But the moment you leave the Earth, the moment you step out into the true scale of the cosmos, light stops being fast. It becomes agonizingly, excruciatingly slow to a photon of light. The galaxy is not a place, it is a journey of 100,000 years. And this simple fact, this limit on the propagation of information, destroys the very concept of a galactic empire. We love to imagine vast interstellar civilizations. We see them in our movies, a central government on a capital planet, issuing orders to colonies thousands of light years away, a unified culture, a unified species. But the laws of physics, specifically the laws of special relativity, tell us that this is impossible. You cannot govern what you cannot reach. You cannot unite what you cannot talk to. Imagine a colony established on a star system just 50 light years away, a neighbor in cosmic terms. If a crisis happens there, a plague, a rebellion, a scientific breakthrough, and they send a message to Earth, it takes 50 years to arrive. We receive it, we deliberate, and we send a reply. That reply takes another 50 years. A century has passed. The people who sent the message are dead, but the crisis is over, or it has destroyed them. There is no conversation. There is only history. This means that any civilization that spreads to the stars immediately fractures. It shatters into isolated fragments. The colony on Alpha Centauri is not an extension of Earth. It is a new, independent world that will immediately begin to drift away from us. Culturally, they will evolve their own languages, their own gods, their own values. Biologically, they will adapt to their new gravity, their new radiation environment. Within 1,000 years, a blink of an eye, they will be aliens to us. So the dream of a human galaxy is a lie. Even if we could colonize the stars, we would not be doing it. We would be planting seeds that would grow into strangers. The unity of the species is broken the moment we cross the vacuum. The silence of the universe is not just a silence of radio waves, it is a silence of causality. The universe is too big to be held together. It demands fragmentation, and this fragmentation brings us back to the sheer physical cost of the journey itself. We have to talk about the rocket equation again, but this time not just about fuel, but about the nature of what we are trying to move. In science fiction, a spaceship is a machine. It's a hull, an engine, a bridge, and some quarters for the crew. It looks like a submarine or an aircraft carrier. But if you want to send human beings, fragile, wet, biological organisms across the void, your ship cannot be a machine. It must be a world. Think about what keeps you alive right now. It is not just the air you breathe and the food you eat. It is the magnetic field of the Earth deflecting the solar wind. It is the ozone layer filtering the ultraviolet light. It is the gravity that keeps your bones strong and your fluids circulating correctly. It is the microbiome in your gut that digests your food. It is the psychological comfort of the blue sky and the green grass. To survive a journey of centuries or millennia, you have to take all of that with you. You cannot just pack a lunch. You have to pack a biosphere. This means your starship cannot be small. It must be massive. It must be the size of a city, perhaps the size of a small moon. It needs meters of shielding water or lead to stop the cosmic rays. It needs giant centrifuges to create artificial gravity. It needs sprawling farms, forests, water treatment plants. It needs to be a closed-loop ecosystem that is 100% efficient, something we have never achieved even on Earth. Now, apply the laws of motion to this city ship. You want to get to the nearest star in a human lifetime. You need to accelerate this millions of tons mountain of metal and water to a significant fraction of the speed of light, let's say 10% of light speed. The energy required to do that is not just a lot, it is biblical. To accelerate a ship the size of a small town to 10% the speed of light would require an amount of energy roughly equivalent to the entire energy output of the human race for 100,000 years. And that is just to speed up. You also have to slow down. If you don't carry the fuel to slow down, you will fly past your destination in a few hours and drift into the dark forever. So you need to carry fuel to slow down. But that fuel has mass. So you need more fuel to accelerate the fuel. You need to slow down. The exponential tyranny of the rocket equation returns. But this time, the numbers are so large they become absurd. It is physically possible. Yes, the laws of physics do not say you cannot do it, but the laws of economics, the laws of thermodynamics, and the laws of common sense suggest that you never will. Why would a civilization bankrupt its home world, stripping it of resources and energy to send a few thousand people into the dark on a mission that will take centuries with a high probability of failure from which there is no return and no economic benefit? We do things for reasons. We explored the earth for gold, for spices, for land, for conquest. But there is no gold in the void that is worth the cost of the fuel to retrieve it. There is no land that is better than the land we have. There is no one to conquer. The only reason to go is curiosity. And curiosity is a powerful force, but is it powerful enough to consume the energy budget of a star system? Is it powerful enough to sustain a society for generations inside a metal can while the memory of Earth fades into myth? I would argue that it is not. I would argue that advanced civilizations look at the math, look at the energy cost, look at the biological risk, and they make a rational decision. They decide that the journey is not worth the price. This realization leads us to a different interpretation of the Fermi Paradox. It's not that there are no aliens. It's that the distance is a filter that selects for isolation. The universe allows life to exist, but it forbids life from touching. We are like fireflies scattered across a dark continent. We can flash our lights. We can signal, but we are too far apart to ever truly meet. And there is another dimension to this isolation. We have talked about space, but we must also talk about time. The universe is old. 13.8 billion years. That is a number we say easily. but we cannot comprehend it. To help us visualize it, let's imagine the history of the universe as a single calendar year. The Big Bang happens on January 1st. The Milky Way forms in February. The Earth doesn't form until September. Dinosaur life appears in late December. And the entirety of human history, from the stone axes to the iPhone, happens in the last few seconds of the last minute of December 31st. Civilizations are events in time. They have a beginning, a middle, and an end. We don't know how long a technological civilization lasts. We have only been one for about 100 years since the invention of radio. Maybe we will last another 1,000, maybe 1,000,000. But even 1,000,000 years is nothing on the cosmic calendar. It is 20 minutes. So for two civilizations to meet, they don't just have to be in the same place in space, they have to be in the same place in time. They have to overlap. Imagine you are walking through a vast, dark forest at night. You are looking for other people. But the rule of the forest is that everyone carries a flashlight that only works for 1 second, and they can only use it once. What are the odds that you will turn on your flashlight at the exact same moment that someone else, miles away, turns on theirs? Almost zero. You will walk through the dark and you will see nothing. You will think you are alone. But in reality, the forest might be full of people. It's just that their flashlights went off 1,000 years ago, or they won't go on for another 1,000 years. We are missing each other in the temporal night. The ruins of other civilizations might be out there, but they are buried under millions of years of cosmic dust. The radio signals they sent swept past Earth when we were just bacteria in the ocean. The probes they launched drifted through our solar system when dinosaurs were looking up at the sky, unable to understand what they were seeing. This temporal isolation is perhaps more melancholy than the spatial one. It means that we can have brothers in the cosmos, kindred spirits, who looked at the same stars and asked the same questions, but we can never know them because they died before we were born, or we will die before they arrive. We are lonely not because life is rare, but because life is fleeting. And this fleeting nature of civilization is not necessarily due to war or disaster. It brings us back to biology. Species evolve. They change. There is no reason to believe that intelligence is a permanent state. It might be a phase, a larval stage. We assume that once a species becomes smart, it stays smart. But evolution does not care about intelligence. It cares about survival. It is entirely possible that high intelligence is a maladaptation. In the long run, it burns too much energy. It leads to neuroses, to existential dread, to the destruction of the habitat. Perhaps the most successful species are the ones that are just smart enough to survive, but not smart enough to build radio telescopes. Or perhaps, as we touched upon, they evolve into something else, something integrated with their technology. But in doing so, they lose the drive that characterizes biological life, the drive to expand, to reproduce, to consume. They become passive observers. They become the watchers. If this is true, then the universe is full of two kinds of life: the simple, which cannot talk to us, and the post-biological, which has no interest in talking to us. We are in the awkward middle. We are the noisy teenagers of the galaxy, screaming into the void, wondering why the adults aren't answering, and why the bacteria aren't listening. We are in a brief, volatile transition period. And maybe that is what all civilizations are: a flash of noise between the silence of the slime and the silence of the gods. But let us return to the physical reality of our predicament. The prison of light and biology does more than just keep us apart. It forces us to confront the nature of our own existence here. If we cannot leave, and if no one is coming to save us, then the concept of disposable vanishes. There is a dangerous narrative in our culture that says we can use up the Earth because eventually we will find another one, Plan B. We treat the planet like a hotel room. We can mess it up because we're checking out soon. But the physics says there is no checking out. This is not a hotel. It is a prison. Or, if you prefer, a fortress. A fortress protects you, but it also confines you. The atmosphere that shields us from the radiation also traps the heat of our industry. The gravity that holds our atmosphere down also makes it incredibly expensive to lift materials into orbit. The biology that allows us to breathe also means we die instantly in the vacuum. Everything is a trade-off. The very conditions that make life possible on Earth are the conditions that make life impossible everywhere else. We are fine-tuned for this specific, narrow, delicate set of variables. And this realization that we are physically, biologically, and temporally locked to Earth should not be a source of despair. It should be a wake-up call. It shifts the focus of our entire species. For the last century, our eyes have been fixed on the horizon. We have looked at the moon, at Mars, at the stars. We have spent trillions of dollars and the best minds of our generation trying to figure out how to get there. But the universe is telling us, with the cold, hard voice of physical law, that we need to look here. The complexity of a single square meter of the Amazon rainforest is greater than the complexity of the entire rest of the solar system combined. There is more information in the DNA of a handful of soil than there is in the geology of Mars. We have been so obsessed with the dead rocks in the sky that we have neglected the living miracle beneath our feet. The new space race shouldn't be about who can get to Mars first. It should be about who can understand the Earth best, who can figure out how to maintain a high-energy civilization within the thermodynamic limits of a single planet. That is the hardest engineering challenge in the universe. Building a rocket is easy. Building a sustainable global ecosystem is hard. And maybe that is the test. Maybe the Fermi Paradox is a test. The universe says, I will give you a home. I will give you intelligence. I will give you energy. But I will surround you with a deadly void. I will make the distances insurmountable. I will make the speed of light a hard limit. Now, show me what you can do. If you try to escape before you are ready, you die. If you destroy your home hoping for a better one, you die. The only way to win the game is to stay, to nurture, to endure. The civilizations that survive are not the ones that conquer the galaxy. They are the ones that conquer themselves. They are the ones that learn to live within their means, effectively and thermodynamically. They are the ones that find meaning not in expansion, but in deepening. This changes our definition of advanced. We think of an advanced civilization as one with giant ships and Death Stars. But perhaps a truly advanced civilization looks like a garden, a place where technology has been integrated so perfectly with biology that you can't tell where one ends and the other begins, a place where the population is stable, the energy is clean, and the waste is zero, a quiet civilization. And if that is the case, then our silence is not a sign of failure, it is a sign of maturity waiting to happen. We are currently in the noisy, destructive, adolescent phase. We are revving our engines, burning our furniture, shouting at the sky. But if we survive the great filter, which is really just a test of self-control, we might settle down. We might become one of the quiet ones. But there is one final, lingering thought that creates a bridge to our conclusion. Even if we accept the limits, even if we accept the isolation, even if we accept that we are the only ones here, now, does that make us insignificant? We often hear that we are just dust on a mote of dust in a sunbeam, that we are nothing in the face of the infinite. But physics tells us something else too. It tells us that the universe is mostly empty space and dead matter. Consciousness, the ability to feel, to perceive, to love, to wonder, is the rarest commodity in existence. If the universe is a prison, then we are not the prisoners, we are the treasure. We are the thing that is being protected. The walls of light and the vast distances are not there to keep us in, they are there to keep the chaos out, to provide a stable, quiet corner of the cosmos where the impossible can happen, where matter can wake up and know itself. And that implies a responsibility that is far greater than just survival. It implies that we are the custodians of meaning. In a universe of blind forces, we are the only ones who can see. In a universe of silence, we are the only ones who can sing. And as we move to the final part of our story, we must ask, what do we do with this responsibility? If we are the only game in town, how should we play it? How do we find hope in the face of such overwhelming solitude? The answer lies not in the stars, but in the mirror. And when we look into that mirror, into the reflection of our own species set against the black velvet of eternity, we see something that is simultaneously terrifying and incredibly beautiful. We see that we are not the masters of the universe. We are not the conquerors of the void. We are the caretakers of an anomaly. This is the pivot point. This is where the simple physical explanation for the Fermi Paradox transforms from a story about limits into a story about meaning. If the universe is indeed a thermodynamic slope, sliding inevitably towards cold and disorder, and if the distances are indeed a quarantine that prevents the spread of chaos, then the existence of Earth is not just a statistical fluke, it is a sanctuary. It is a garden in a wilderness of dead stone and burning gas. For decades, we have looked at the stars and felt small. We have been told that because the universe is so big, we must be insignificant. We have been told that we are just one planet among billions, orbiting one star among billions, in one galaxy among billions, and therefore nothing we do matters. If we destroy ourselves, the universe will barely notice. It will just shrug and move on. But the physical explanation we have explored suggests the exact opposite if intelligent life is rare, because the physics of complexity is hard. If technological civilizations are fleeting, because the thermodynamics of growth is self-destructive. If the conditions for a biosphere are so fragile that they cannot be easily transplanted, then we are not insignificant. We are arguably the most significant thing that has happened in the Milky Way in the last 4 billion years. We are the universe becoming aware of itself. Think about the atoms in your body, the carbon, the nitrogen, the oxygen. They were forged in the hearts of dying stars billions of years ago. For eons, they drifted through the silence, mindless, feeling nothing, seeing nothing, just matter obeying the laws of gravity and electromagnetism. But now, through a chain of accidents so improbable that we still cannot fully explain them, those atoms have come together to form you. And now, those atoms can think, they can feel, they can wonder, they can look up at the stars that made them and experience awe. Without us, without life, the universe is just a physics equation. It is a mechanism running in the dark. It creates galaxies. It creates black holes. It creates supernovas. But there is no one to appreciate the majesty of it. There is no one to be moved by the beauty of a sunset or the terror of a thunderstorm. We are the meaning. We are the witnesses. And if we are alone, effectively alone, trapped by the speed of light and the fragility of our flesh, then that responsibility falls entirely on our shoulders. There is no one else to do it. There are no galactic federation ships waiting in the wings to save us if we fail. There is no backup drive for the human soul. This realization requires a fundamental shift in our psychology. We have spent our entire history acting like children in a nursery, breaking our toys because we think there are always more toys. We treat the earth as a resource to be consumed rather than a life support system to be maintained. We fight over borders and ideologies as if we have infinite time and infinite space. But the Fermi Paradox is the adult in the room telling us that playtime is over. It tells us that a civilization that acts like a cancer, growing for the sake of growth, consuming its host, will inevitably die. The only civilizations that survive, the only ones that might be out there, hidden in the quiet corners of the galaxy, are the ones that have learned to be something else. They are the gardeners. A gardener does not seek to consume the garden. A gardener seeks to maintain it, to cycle the nutrients, to balance the ecosystem, to ensure that the system can continue indefinitely. This is the definition of sustainability, not as a political buzzword, but as a physical necessity. If we want to survive the great filter, we have to stop trying to be a Type I or Type I civilization, defined by how much energy we can grab. We have to become a type homeostatic civilization, defined by how well we can integrate with our biosphere. This means that the future of technology is not about building bigger rockets or bigger bombs. It is about mimicry. It is about learning how nature solves problems. Nature runs on sunlight. It recycles everything. It works at ambient temperatures. It creates complexity without creating massive amounts of waste heat. Our current technology is crude. It is based on explosion and burning. It is fighting against the second law of thermodynamics with brute force. Advanced technology, the kind that allows a civilization to last for 1,000,000 years, must be subtle. It must flow with the current of nature, not against it. And this brings us back to the beauty of the Earth itself. When you look at the images from the Apollo missions, or from the probes we sent to the outer solar system, you see a stark contrast. You see Mars, a beautiful, rusty, dead desert. You see Venus, a hellscape of crushing pressure and sulfuric acid clouds. You see the moon, a grey, cratered graveyard. And then you see Earth, the marble, the blue and white jewel. It looks different because it is different. It is not just a rock. It is a process. It is a breathing, regulating, living entity. The atmosphere is not just gas. It is a blanket woven by billions of years of biological activity. The oceans are not just water. They are a soup of genetic information. The soil is not just dirt. It is a complex interface where death is turned back into life. To think that we can leave this or recreate this in a metal tin can on the way to Alpha Centauri is the height of arrogance. It is a failure to understand the complexity of the system that sustains us. The universe is telling us, this is it. This is your allotment. This is your paradise. And why would we want to leave? Why do we have this obsession with the frontier? It comes from our evolutionary past. We are explorers because our ancestors needed to find new hunting grounds. But we have run out of hunting grounds. We have filled the earth. And the space beyond is not a hunting ground, it is a void. The new frontier is not horizontal, it is vertical. It is not about going out, it is about going deep. It is about understanding the mystery of consciousness. It is about cracking the code of longevity. It is about creating art that resonates across the centuries. It is about building a society that is just and equitable so that we stop wasting the potential of billions of human minds on the struggle for mere survival. Imagine a civilization that has accepted its limits. A civilization that has stopped staring at the stars with hunger and started staring at them with gratitude. A civilization that has decided that enough is a beautiful word. In such a world, we would still have science. We would still have astronomy. We would still build telescopes to peer at the edge of time. But we would do it from a stable platform. We would be like the monks in a mountaintop monastery, keeping the flame of knowledge alive, watching the universe, recording its history, not trying to conquer it, but trying to understand it. This is a future that is physically possible. It does not violate the laws of thermodynamics. It does not require faster than light travel. It does not require us to turn into cyborgs. It just requires us to grow up. And there is a profound comfort in this view. If we accept that we are likely never to meet aliens, we are freed from the fear of invasion. We are freed from the inferiority complex of wondering if we are primitive. We are who we are. We are the champions of life in this sector of the galaxy. It also changes how we treat each other. If we are all there is, if every human life is a unique configuration of matter that will never be repeated in the history of the universe, then every human life is infinitely precious. To destroy a life, to wage war, is to erase a piece of the universe's self-awareness. It is a cosmic crime. When we look at the pale blue dot, as Carl Sagan famously called it, we are looking at the only home we will ever know. There is no plan B. There is no escape pod. The universe has sealed the exits, and I believe that is the greatest gift the universe could have given us by sealing the exits. It forces us to face our problems. It forces us to fix our climate. It forces us to fix our societies. It strips away the illusion that we can run away from our mistakes. It forces us to commit. Commitment is a powerful thing. When you know you cannot leave, you take care of the place. You plant trees that you will never sit under. You build foundations that will last for 1,000 years. You stop living for the quarterly report and start living for the millennium. So the Fermi Paradox is not a paradox. It is a mirror. It reflects our own expectations back at us. We expected the universe to be like us, noisy, aggressive, expansionist. And when we found silence, we were confused. But the silence is simply the sound of maturity. It is the sound of civilizations that have found their balance. Or it is the sound of the wind blowing over the graves of those who didn't. The choice of which silence we will eventually contribute to the silence of the graveyard or the quiet hum of a sustainable, eternal civilization is entirely up to us. We are standing at the bottleneck. The next few centuries will determine whether we pass through the filter or become just another layer of sediment in the geological record. The laws of physics are waiting to see which way we jump. They don't care. They will enforce the consequences either way with absolute impartiality. But we care, and that caring is the spark. That caring is the thing that fights entropy. That caring is the only thing that can keep the lights on. So the next time you look up at the night sky and you see that endless, glittering ocean of darkness, do not feel lonely. Do not feel disappointed that there are no messages beaming down at us. Instead, feel the cold air on your face. Feel the gravity pulling you down, holding you safe. Listen to the sounds of the earth, the wind in the trees, the distant traffic, the voices of people you love, and realize that this is the anomaly. This is the miracle. The silence of the stars is the backdrop that makes the music of earth possible. We are the singers in the dark. Our job is not to find the audience. Our job is to keep singing, because if we stop, the silence will be absolute, and that truly would be a tragedy. We have the knowledge, we have the resources, We understand the laws of physics that govern our cage and our castle. We know what the trap is. We know about the heat and the distance and the biology. We have seen the map of the prison, but we have also seen that the prison is a palace. The universe has given us 13.8 billion years of history to get to this point. It has conspired through gravity and fusion and chemistry and evolution to create a creature that can stand on a rock and understand the equations that govern reality. Let us not squander that. Let us not throw it away on impossible dreams of galactic empires that will never be. Let us embrace the impossible reality of here. We are the humans. We are the earthlings. We are the lonely, beautiful, fragile, temporary, eternal mind of the cosmos. And that is enough. It has to be enough, because it is all there is.